Good evening, everyone. So my name is Marat. I'm a software engineer at Booking.com, and today I will try to explain how we use agents and how to build how to use agents in secure demanding services. But before I start, how many of you are mostly engineers? Because I know that there are a lot of product people. Please raise your hands if you are engineer. Oh, well, it will be very boring for you. Sorry. Yes. Let me begin. If you ask a security engineer about AI today, you will get two different responses. One will be super excited. We can ship a lot of code. I produced 29 MRs, you know who I'm talking about, just for yesterday. And another reaction would be it's scary. We cannot control the code we produce, so we should limit the blast radius. And a year ago, I would have been the same person who would say that, yes, we should limit agents because agents are not great. All right. So yeah, let me tell you a story. A year ago, I started experimenting with agents, and I decided to give agent a super simple task, which was update dependencies and run CI, merge it. If CI is green, merge it. Sorry. Yes. But agent decided to do something else. So it updated dependencies, tried to build, got an error, decided to fix an error, decided to leave project directory for some reason. I turned out for 30 seconds, turned back. It tried to rewrite my Maven configuration. It's a Java dependency manager. So I luckily caught it on time, but it led me with two choices. Either look at this thing constantly or approve everything, which won't save me time. I have junior developers, so I don't need another junior developer inside my laptop. Or I can build a playground which will restrict agents, let's say, in a way. So, which leads me to the, which leads me to the myth number one. What I tried to do after I had this incident with agent doing some things on my computer, by the way, it wasn't some malicious intent. It was taught to be like that because I think somewhere in reinforcement learning, it tried to solve problems with all possible tools that it had at the moment. So my first approach was to try to learn agent to behave good. So I tried to create skills. I tried to tweak with prompt. I decided to taught it to follow the security standards that we have. And yeah, here we have examples what I tried to teach. So which is do not. Oh, you cannot see it. Okay, I will read it for you. Do not make mistakes, never hard-code secrets, and follow PCI requirements. PCI requirements, it's special requirements. If you work with credit card details, you have to follow them. But reality is that it won't work, unfortunately. So prompt injections are inevitable. They will happen no matter what you're going to do. So prompts are more like guidelines, not guardrails. And you can't do anything about that. That's sad, but yeah, that's reality we live in. So if you rely just on a prompt for restricting your agent, you play in casino. Because one day it will work as you expected, the other day you will have to find a new job because you was fired. So if you cannot trust the brain of agent, what you can do, you can constrain the body and build a playground for the agent. And in technical terms, playground, it's just a sandbox for the container. For me, it was a Docker container. Where I gave restricted permissions to the agent. So first restriction is file system limit. So I limited access for the agent and literally could see just work directory, nothing else. Second restriction is command whitelist. This is on you. You decide for yourself where you draw the line of atomicity autonomicity for the agent. For me, it's build commands or some fetch from known hosts that I'm aware of, like my internal companies or, I don't know, Anthropic.ai. So, but if you feel lucky, you could do whatever you like. And third one is no secrets. So for the agent, there should be no way to receive secrets in the context. And it's not about like Anthropic will get your, or some other AI company will get your secrets and somehow use it. It's more about sanity of the agent, because someone might exploit your agent, and if it doesn't have opportunity to fetch secrets, because you use skills and secret storage, then you are safer than if it were hard-coded in the skills. If you heard about OpenClaw, you know. Okay. So we have a playground, but it's not enough. So what we need to do some security review, because while agents still have a playground, it still can produce malicious code or bugged code and ship it to production. So what you want to do, you want to do some kind of review. And some people think that AI will replace security officers and do review for us. Just let agent to explore the code and everything will be fine. Other people think opposite, like you cannot leave AI to review your code, and only humans should do that. It's a human craft. My answer to it that it should be both. So it should be humans and LLMs and different LLMs. I will read all that, sorry. So what I do, I use multiple LLMs to review important pieces of code, because one model can start reward hacking without doing anything useful at all. This pattern called cancel, if you read Andrei Karpathy on X, you probably know about that. So he had like a vibe-coded project for this. It utilized the same idea. You have different LLMs. Each LLM has a different role. In my case, it's a PCI expert, the reviewer, and the arbiter. And each role runs on a different LLMs. Each role runs on a different model. So we try to separate it as much as possible. And another important note, so they review your code, they give edits, and they try to achieve consensus. So kind of like doctor would. So if you have like serious disease, you want to have second and third opinion. And if they cannot achieve consensus on time, they all prepare reports, and it goes to human to review. This brings me to the whole feature workflow as we have it right now with the console and everything. So first we receive a feature and we start brainstorming with agent. Oh, it's here. It's brainstorming. So what that means that, for example, you got from your PM, stakeholders want that, you put that to the agent, and then agent starts asking you technical questions, you start answering, so it's kind of like interview, you enjoying yourself, and then agent and you fill all the gaps in this feature request. After that, agent produce plan. It's a small list of tasks which can be done most of the time independently. So, and you have like two documents. First document, after brainstorm, you have a design document. After second implementation plan, you have implementation plan. And after that, you ask your agent to produce subagents. I found it the most efficient way because each subagent has empty context, so it can utilize and fix this task the most efficient way. And after that, console comes to the play and review happens. Okay, 1 second. So yes, all these things, if you like use agents a lot, it looks familiar because it is, except for the console. So console is something that I added, but yeah, you all recognize all this. important piece here is that you still have human in the loop, like not me, some developer or someone else. But what this workflow does, it amplifies your capacity so you can deliver more. Of course, you pay for it with less context knowledge about business domain, but you achieve more capacity for future deployment. But it's not always that great. So we have now Playground, we have console to review, we feel super secure, but 10 years of experience with fintech development, in fintech technologies, taught me one thing, that something eventually will go wrong, and what you want to have audit for everything. So that's another safety net that you want to have. You want to log every interaction with agent. And as I said before, you have design document, you have implementation plan, you need to store them somewhere. It could be Git repo, it could be something else, you name it. But important part that you want it to be stored. And what we also do, we store sessions that developers have with agent, because this will help us to understand what went wrong. So, yeah, to summarize this slide, audit as much things as possible, because when something goes wrong, you want to know what went wrong. And this brings us to the third thing, like all these skills, console, agents, playground, all that things. It seems like too much to start with. It's hard to sell to the business because you need to invest a lot, but you always can start with small things. The smallest possible thing, I think everyone who raised the hand at the beginning already have it. You can start with writing Agent.md. So most of agents already have like a built-in initial command, which allows you to create this file. But I would add one more thing. Don't be lazy and read it, because sometimes agents tend to put some meaningless things into it. Oh, sorry. So yes, you cannot see it again. I wish I knew that this has this environment. But you have different steps. So first step is Agent.md. You create it. It's super simple. It's like 10 minutes and another hour to read it. Second, you you find specific routine tasks in your team, and you try to build a skill for that. Why you need a skill? Because you want to have reproducible results. For example, like, I don't know, you have a special convention for the Git commits. So what you do, you create a skill and you taught LLM how you want your Git commits to look like. And this will help you to automate small bits and pieces that you have in your team. So then when you have skills, you have other cool things such as console, such as subagents and all that things. And this domain evolves super quickly. When I was preparing the slides, Anthropic didn't release their Teams feature. So you might want to try that. Idea here is that no one knows what sticks, so you try a little bit of everything, and whatever sticks to you, to your team, it works, you adapt it, and you live with it. You don't have to start big, you can start small and incrementally develop what you want to do. And let's wrap up. What we have, what checklist we can get from this presentation, it's no secrets. No secrets in LLM context. So secrets might be present on your machine, may be present in Docker container, but please don't put them into context. It won't end well. Build a playground, try to restrict LLMs. So if you won't restrict them, then you have to constantly watch after them. Human approval. Humans are important, although like we don't know, but you want human to be present in the loop. Do cross-validation. It doesn't have to be cancel. For me, it's cancel, but what you want to do cross-validation, and you want to leverage this thinking capacity that LLM provides to you. Audit everything. this is the most important part. Like, don't try to audit everything. First, it will help you to shape your skills and everything, because you will see how people behave with your models or with your skills, and it will help you to increase velocity of your team. But important part, if something goes wrong, you will know what went wrong. And start simple, create Agent.md. I think you all did that, but doesn't hurt to mention it again. All right, that will be all from my side. Any questions? And also, I don't have product to sell, I have me, so please scan and add me on LinkedIn. Yeah, and questions.
Hi, hello. Thanks for the talk. I had a blast. I have a question, though. That's why I grabbed the microphone, obviously. Don't you think that this is basically kind of moving the goalpost further? Like, the actions that you mentioned, they obviously improve the security and safety of the implementation, but they don't change the nature of the thing that agents are still stochastic, that they're not deterministic. So it may work, basically it works 5 out of 10 times, for example, at the beginning, then you implement the steps that you suggested. And now it works like 9 out of 10 times, but it's still random at times. When would you feel safe with letting it run?
I would say, well, yeah, I'm really security biased. I mean that most of my career I spent in security domain, so I think with security in mind, and yeah, I cannot break things, unfortunately. I wish, but you all want to live in hotels that you paid for. And answering that this was the hardest thing to explain to everyone, that agents are not deterministic, and what you want to do, so you either spend more time recovering from the incidents, or you spend more time when you prepare features. So you might use, if you say like 9 from 10 times agent does good, so you run 100 runs, right? You implement this implementation plan 100 times, and you try to catch everything. So for business, the most important part would be that stability. So if it's still flaky, you have to build tools that will catch this flackiness. If tools weren't present and you failed, that means that you need to add these tools for the next run. So gradually, it will be like good enough, as good as humans are.
Thank you.
Any more questions?
Thank you.